Hello everyone, welcome back to Rearrangement series part 5. In today's series, we will be studying about Hofmann rearrangement. So stay tuned with ChemONotes and please subscribe, share and like the channel. So let's begin. Grab your notebook. So let us start. The Hofmann rearrangement reaction is basically a transformation of primary amide into primary amine. So what is a primary amide? You can find here amide. Amide is nothing but a functional group containing C double bond O NH2 group. So this is a functional group which is known as primary amide. So this primary amide is converted into primary amine, where you will find that the carbonyl carbon or a carbonyl group is lost. So whatever is the product you will be getting, that will be one carbon less than the starting material. So let us see the reaction. So this is your primary amide, that is R C double bond O NH2 is a primary amide. When it is treated with aqueous NaOH and bromine, okay, what you are going to get is you will be getting a isocyanate. So here you will find there is a rearrangement taking place. So in the presence of Br, okay, bromine, what happens is there is a rearrangement taking place, where R has been shifted to nitrogen here. R has shifted to nitrogen, and you will be getting an intermediate which is called as isocyanate. So this reaction is similar to your Curtius reaction, rearrangement reaction, where the intermediate step is same, that is isocyanate. Now isocyanate loses carbon dioxide gas and you will be getting a primary amine. So basically when it is treated with water, what happens is, and if you are going to heat it, carbon dioxide will be lost and you will be getting a primary amine. Okay, so let us see the mechanism of this Hofmann. So student, let us see the mechanism of Hofmann rearrangement. So the starting material we will be taking is amide, primary amide. Okay, so here you will find R C double bond O NH2. Okay, so when it reacts with aqueous solution of NaOH and in the presence of bromine water, the starting thing is your NaOH OH minus is going to grab a proton. So let us show that OH minus from NaOH is going to grab a proton. Okay, this proton will be grabbed and the electrons will be shifted to nitrogen. So your first step, what you will be getting is, this is the first step, that is R. Okay, there is shifting of double bond, and once the electrons are shifted, so intermediate step will be this. Let me show it here. R C double bond O N H, and nitrogen will carry a minus sign. Okay, so this electrons will be shifted here and it will, oxygen will carry a negative charge. So this way you are going to get the next step. Okay, so after this, the next step is they are going to react with bromine, and what happens is you will find that the bromine which is there from Br2, one of the bromide ion is going to get grabbed, like negative charge of oxygen will again come back to its original place, and this is going to grab a bromine from bromine molecule, and this way one of the bromide ion gets eliminated, that is Br minus gets eliminated. Okay, so this is the mechanism which takes place, and what you are going to get it, R C double bond O N, C here student, C N, so it becomes single bond, N H, already H was there, and Br, the nitrogen has taken the Br atom. So here you will be getting this step. After that, what happens is your OH minus is going to, instead of your H2O molecule, what happens is the OH molecule, let us show it as OH minus ion from water molecule, is going to grab the proton again. Okay, and it will shift here once it shifts here, you can either show it as a minus sign or you can show direct shifting of the R bond. Okay, so what I've done is I have just shifted the pair of electrons from here, and oxygen will carry a negative charge. So here this is the step we are going to get, that is RCO minus, you can find here RCO minus double bond N Br. Okay, so OH minus has grabbed the proton, OH minus has grabbed the proton, and ultimately what has happened is it has eliminated the H2O. H2O gets eliminated. Okay, so this way you are going to get the next step. Now further what will happen, the electron pair from oxygen will again get shifted down. Okay, they'll try to shift again back. Now while doing this, there is a rearrangement which is going to take place. Okay, this R is going to shift to nitrogen and it will throw out the Br. It is going to throw out the Br. So here Br will get eliminated. Br will get eliminated. Okay, and already one of the Br was eliminated before, so you get bromine back. You get the bromine molecule back. Now after this rearrangement step, what you are going to get is, after this rearrangement step, we are going to get a isocyanate, that is Rn double bond C double bond O. Okay, so isocyanate. Now once the isocyanate is formed, next step is you are going to treat with water. Okay, next step is what, you are going to treat the isocyanate with water. Now when isocyanate is treated with water, simple step take place, that is you will find that the hydrogen is here, this pi bond of nitrogen and sulfur gets, okay, the addition of water takes place here, that is hydrogen is grabbed by nitrogen and OH is grabbed by your carbonyl group, that is the lone pair of electrons on nitrogen will grab the proton and this will shift here. Okay, and this way you will find that there is a pi bond of nitrogen and carbon will break down here and you will get a single bond. So basically there is addition of water molecule on nitrogen carbon double bond, and the intermediate step which you are going to get it, I'll write it down here, that is Rn. Okay, hydrogen is grabbed by nitrogen, there is single bond here, there is OH and double bond O. Okay, so this is the step which you are going to get, and the last step is what will happen is that you can even show this OH as, because we'll show some rearrangement taking place or removal of your carbon dioxide gas. So what is going to happen is nitrogen molecule, okay, will first of all here this is going to take place and this bond will break and it will give nitrogen its lone pair again. So it will carry, nitrogen will carry a minus charge and this proton will be grabbed by that minus charge, and ultimately there is release of CO2 gas and you are going to get a primary amine. Okay, primary amine, that is RNH2. RNH2. So let me show, this is the last product which we are going to get and which is known as what, primary amine. Students, do you know why it is called primary amine? As nitrogen carries only one R group. Okay, nitrogen is attached to only one R group, that's the reason why it is called as primary amine. If nitrogen was attached with two R groups and only one hydrogen was there, then it would have called secondary amine. I think this is known to you. So this is how the mechanism goes on, and ultimately from primary amide we are getting a primary amine. Okay, so this is a step by step mechanism, but next thing I'll show you a simple trick to remember this during solving your CSIR-NET or any other competitive exam paper. What you have to do, see the first one. The first one, if you find here, it is nothing is there means CH3 is there. Okay, student, CH3 C double bond O NH2. When treated with bromine, in the presence of aqueous NaOH, obviously it is going to undergo what Hofmann rearrangement reaction, and you will find the amide has been converted into primary amine, plus there is loss of carbon dioxide gas. So we have already stated in our definition of Hofmann rearrangement that there is elimination of carbonyl group. Okay, carbon dioxide gas is released and one carbon less product you get. See, if you see here, how many carbons are there in the starting material? That is 1, 2, 2 carbons and one NH2. So in the final product you will find only one carbon is left out and NH2. Okay, so one carbon has lost along with oxygen. That means this middle part is going to get converted into, or we can just highlight that and show it in this way, that this carbonyl along with NH2, that is amide group, has been converted into simply amine. Okay, so only this much you have to remember, and this is same like your Curtius rearrangement reaction where the amide group has been converted into NH2 group. Now students, is it simple to answer this question? Next question, because you don't have to write the full mechanism. Now you can directly write the answer or select the answer from the given option. What is the given option you will get? This is CH3, CH3. It is a secondary group where you will find, so here it is, this group will get converted into NH2, okay, plus CO2. So this is the product you are going to get. Similarly here, so what we can do is we can just highlight this. So this has been converted into, amide has been converted into your amine. Okay, now next one is very simple. It is without seeing, if you only go through the reagents and you can understand that there is what a formation of an tertiary. Okay, this is the CH3, that is this carbon carries 3 CH3 groups and NH2 group. So if we write it this way, this is the product what you are going to get. Okay, so this is this is nothing but your Hofmann rearrangement reaction. So let us see the next one. Okay, before we go to the next one, let me write this again product very properly. I'll just write it down this way, that is CNH2. okay, there is CH3 group, CH3 group and CH3 group plus CO2. Now let us go to the next one. Next reaction which was asked in NET exam is a benzamide. Benzamide reacts with bromine and aqueous NaOH. Again, it is undergoing Hofmann rearrangement reaction. So simply you will be getting a benzene ring with NH2 group. So it is aniline. Okay, formation of aniline from benzamide. Similarly, here you can see the next one. Now I think students you can write down very easily. There is simply what? CH3, as I have already told you the trick, that you have to remove CO2 group, and okay, so this is the product you should get. Now in Hofmann rearrangement, same like Curtis rearrangement, that what happens is the carbon which is a chiral carbon, it will retain its configuration. Okay, it will retain its configuration while rearrangement takes place. So this also you should remember, because in the options given they can ask, they always give us the configuration, different configuration, and we have to select among the 4 one answer. So you should remember whatever is the starting configuration of the chiral carbon, same will remain after rearrangement. Okay student, now the next one, see here, what is the next one? It is a cyclohexane having CH3 group, and the amide group will be removed and there will be NH2 group, simply NH2 group. Okay, So this is the product you will be getting. Now next one is, let us see the next one. Again the same, write down the benzene ring. Okay, there is a cyclobutane along with benzene ring, and the amide groups gets converted into amine. Okay, here the amide group gets converted into amine. So let me just highlight it. What happens is, you will find that this group we have converted into amine group. Okay, so this is the trick which you should follow. If you see the reagents on the arrow as bromine, NaOH, methanol or water, and here they have given minus 40 degrees Celsius. Okay, so this is going to undergo which reaction? This is going to go your Hofmann rearrangement reaction. Sometimes they even ask us the name of the reaction in the exam. Okay, they give the product, everything, and they will ask you which reaction it is. So it is a Hofmann rearrangement reaction. Similarly, here you can see now, here you have to find out the proper. Now this reaction is slightly different, that is you will be getting, let me write the product. This is what you are supposed to get. Okay, here you will find that this has been converted into NH2 without changing the configuration, and this is your C double bond O OH. Now students, you will not stop here, because both the amine group as well as carboxylic acid group are on the same side. So there is further reaction which will take place, that is this. That is, nitrogen carries a lone pair. So that lone pair is going to attack on the carbonyl, and there is elimination of water molecule. And at last, the product which you should get is this. Okay, you are going to get a product that is NH, okay, and C double bond O, and there is a bond between nitrogen and carbon. Okay, so this way, and there is elimination of water molecule. Water molecule will be it will get eliminated. So this is how you can further do the reaction. Now for CSIR-NET exam, they already give us the options, so you should know from the option and try to see which will be the correct option. Okay, so this is the product you should get at the final for 8th problem which is given here. Now the next one is, such type of questions are also asked in the CSIR-NET exams, that is, suggest the correct order of reactivity of Hofmann rearrangement reaction. They may not give the name of the reaction, but they can ask you the reactivity. Now for Hofmann rearrangement, you will find that the electron withdrawing groups are not going to be favorable for the rearrangement of the groups. Okay, but electron donating groups will be favorable for your Hofmann rearrangement reactions. Okay, so out of these 4 groups which they are given, the amides are given to us. You can see that the first one is benzoamide, second one is paramethyl benzoamide, okay, third one is paranitrobenzoamide, and fourth one is uh, that is parachlorobenzoamide. Now among this, the most least which is going to follow the Hofmann rearrangement is third structure. Why? Because there is a nitro group. So nitro group is going to withdraw the electrons. So this is not going to favor the Hofmann rearrangement. So let us write the reactivity series, that it will be, second will be the first one, okay, because CH3. So because of inductive effect, it will favor the Hofmann rearrangement. Then it is first one, then your fourth one, and the last one will be least which is going to follow the Hofmann rearrangement will be the third one. Okay, so this is your series, and you should know that electron releasing effect, the migrating group increases the reactivity of Hofmann rearrangement. Okay student, so this is about Hofmann. In our next video we are going to compare our Hofmann, Curtius and Lawson's rearrangement reaction. So stay tuned with ChemONotes. Thank you for watching ChemONotes. Stay tuned with ChemONotes. For more videos on rearrangement series, you can hit the playlist button and you can watch the other parts of rearrangement reactions. The students who are appearing for chemical science, they can find other videos on stereochemistry, polymers, NMR spectroscopy also. So please watch them and stay tuned with ChemONotes. And if you like the video, please subscribe, share and hit the bell icon so that you can get the notification. So bye till then.